cloud. Perfect. Good morning, everyone. Today we're covering Tauri, and Daniel is going to walk us through building native desktop apps with Tauri and web tech and some instrumentation of the app as well. Daniel, I'll let you take it away. If anyone has questions, feel free to post in chat or unmute yourself briefly. We're a small crew here. We'll go for about an hour. Daniel, you okay with sort of questions as we go?
Sure, no problem. I mean,
Great.
there will also be the opportunity because there's a couple times I'll be doing builds and it will take, a minute or something. So that would be a great time to answer questions if you have them.
Perfect. Awesome. Take it away. It's all yours.
All right. So today we're going to be talking about Tauri, which is, as you can see, if you're looking on the screen I'm sharing right now, it's what we're positioning as an alternative to Electron. And I'm not going to go into all of the details of the philosophy of Tauri. I did that pretty well in the fireside video that we recorded on YouTube. I think that link is available somewhere. And what I do want to talk about, though, is why size matters and why smaller is better. I was contacted, as a matter of fact, 2 days ago by a developer from a very popular app. I'm not going to name the app because of kinds of disclosure, something around torrents. And the problem that his team faced at a certain point in their success was that they had petabytes of transfer, and they had over 100 mirrors. And that's because their app was pretty big. It's bigger, or it was bigger than these 50 megabytes that a pretty vanilla Electron app will create for you. They were shipping something like 130, 140 megabytes. And, when you tear apart a binary that's been made with Electron, what you find are things like the ASAR. That's kind of the JavaScript code and HTML that is in basic plain text. You can just easily reverse it with a simple command, and you can investigate the entire app. And there's a lot of stuff that just gets shipped for every single instance of an Electron app. You've basically got a specific node runtime, and you've got a specific Chromium runtime. And for every app, you've got this. And then what happens is your system starts to bloat, because Chromium is one of those apps that just takes as many resources as it can get. And Node is also known for its hard limits, right? Like it'll kind of stop consuming memory at a certain point, which is going to have adverse effects on your application, right? It's single threaded and all this stuff we know. And what we're trying to accomplish with Tauri is we're using the system web view, which means we don't have to ship Chromium. Generally speaking, they're based on WebKit, but we also are not shipping a Chromium we're not shipping a Node runtime, because we're actually creating all of the logic with Rust. So I'd like to talk a little bit about how you can get some more information on how all this works. And that's our recently relaunched website, where not only do we have a section that describes what Tauri is. Oh, look, there's the video. But also goes into the nitty gritty about how to set up your system. And I'm not going to cover that today because it's different for Linux. It's different for Windows with WSL. It's different for Mac OS. And, that's why we've got our individual setups here. And we also talk about, the way that Tauri works. And so that's kind of where I'm going to move into this danger zone of live demos. I didn't make any sacrifice to the demo gods today, which is probably going to come back to haunt me. However, I'm pretty confident we'll be able to make it through without too many hiccups. So the way that Tauri works is we have a CLI and we have a bundler. The CLI is currently written in Node.js and the bundler is written in Rust. And the reason why we started in Node.js is because when we started a year ago, we were totally fresh in Rust. We did what we knew how to do, and I'm sort of happy that we did that, because what it's allowed us to offer is a relatively robust TypeScript-based system that interfaces with your common node modules. And so I think I'm just going to show you an example of how I would do that. Here we have a common method of creating a new Tauri project. So just walk you through it. You create a new directory, you change into that directory, you run yarn init, and we'll create a new NPM project. And then we're going to add Tauri to that project, and then we're going to initialize it. And I'll just do that here and enter through it. And
Okay,
so right
so
now what it's doing is it's adding our NPM module. And the reason why this is important is because, in a web view, all you have is JavaScript. So we have to have a way to interface between the JavaScript and the Rust. And the way we do that is with message passing. And we have a JavaScript API that corresponds to the Rust API. So in end effect, what you kind of have is something like an actor model where the web view is able to maintain its own state and send a message to the Rust backend. And the Rust backend is able to accept a message and send a message to the web view front end. And it can also, at any time in the event loop, also send events to the web view. I mean, you could potentially have some kind of WebSocket that only exists in Rust, and you would be able to listen to that event, and when an event comes in over the socket, you could push that message to the web view, as an example. So,
and that is WebSockets is what you're using for the communication?
No, we do not make any presumptions about that. As far as the communication between the web view and the Rust backend go, we're able to leverage the specific method of communication between those two. How should I describe this? Basically, WebView itself is a collection of C, C++, and Objective-C headers that allow other languages like Rust or Python, NIM, C++, whatever, to bind into the system interface for the WebView. And the way that that works is the parent, in our case Rust, the parent, the one that spawns the web view, is also able to communicate through a direct channel with its child web view, right?
Right, depending on the operating system that's built into each of the web view instances per operating system.
Right, and they all, I mean, okay, it gets hairy because, for WK WebKit, it's a slightly different approach than it is for Edge HTML, as it is to the Linux one, but all basically follow the same principle, that the administrating backend is able to communicate with the front end through a very specific messaging system. So
Great.
I'll show you a little bit more about that when we get to tracing. But right now I wanted to kind of show you what you get when you create this app. You've initialized Tauri, and I'm just going to make sure that our sanity check passes. So we have a command called Tauri info, and what that does is it just makes sure that Rust is at the right version, and that the bundler is also at the right version, that the Tauri is there, that your node, my node is out of date. I'll deal with that later. And so everything is more or less okay. Now, when you create this, we've installed the Tauri package. So I'm going to just show you what that looks like. And I just zoop up. And what we are looking at is our, I want to show you the dist folder because that's where things get kind of exciting for us. What we have here are the API bindings that are used from the module perspective of JS. So you can import this, you know, if your framework is using ES6, for example, you can import and tree shake whatever you want, and it probably won't work. And I'm going to explain why. The reason why is you can import the JS side of things, but you have to declare what is available on the Rust side. And we do all of our configuration in the Tauri conf.json file. And that's this one. Now, this is a kind of minimal setup because I'm going to actually be walking us through our validation app. It's the one that you can download from our website at the top of that little bar. This is what we're using to validate that our API is working, right? And so what we have here is a whitelist. Now, the whitelist is a way for us to define which parts of the API we want Rust to make available, because we're also going to be tree shaking things out of existence, which gets important once you become a little more security conscious. If you don't need access to the file system, there's no reason, A, for the backend to have any kind of endpoints that do anything with the file system. And you also don't want that in your front end. I mean, it's basically this classical tree shaking that we're doing on both sides here. So, I mean, I've talked a lot. I haven't shown you much.
Security is actually one of your goals with Tauri, isn't it?
We've actually tried to look at the shortcomings of the ecosystem and consider those from the foundation of our architecture. Personally, it's one of the scariest moments is when you open up Reddit/cybersecurity and something comes up like a keychain exploit in iOS. You know, these vulnerabilities are everywhere, and I mean, for those of you out there who are reading this in the future or watching it in the future or are with us today, my hugest concern with Electron aren't necessarily the 0 days, it's the 1 days. And a 1 day is basically an exploit or a problem has been discovered and it's been published and everyone knows about it, and that change to the code hasn't trickled down through the ecosystem yet. I mean, in some cases in Chrome, it can take a couple weeks where you've got a 1 day that is open for that long and everyone knows about it, right? It's an endemic problem of responsible disclosure in the security ecosystem, which is another discussion entirely. So I'm just going to go back, or wait, maybe I can switch. There we go, I was set up. All right, so let's just pretend for a moment we are not using any kind of front-end framework. We're not using Svelte, we're not using Vue.js, we're not using React. Of course we could, but we want to keep things vanilla. And that's how we approached our examples app, the one that we're going to be looking at today. We didn't want to be reliant on some third-party framework breaking and then confusing our build pipeline, right? So the way that we tell Tauri where to source itself for the dev process is from this build. That's the dev path. So right now you can see that we're sourcing the dev window, which I'll just open up right now or start building, we source that from the dist folder here. That's this one. So the dist folder has an index.html. That's what we're looking at. I mean, this is just basic stuff. You've got CSS, you've got some HTML, and you've got some JavaScript. And then we're just doing some very vanilla script evaluation right there. To show you that, let's just, let's pick dialog just to see what that looks like. Here we go. And this is maybe the time where my system starts to crash. Oh no, it didn't. The thing about the Rust compiler is that it's greedy and it will take all of your cores. And actually, I kind of think that's a good thing. So right now, what's happening is the Tauri is getting built. If you notice, it's 161 of 163. That means that there's about 163 crates. Crates are in Rust basically what a module is to NPM. And because I was doing this before, you know, getting ready for the meeting right now, we don't have to build these all from scratch because that just takes a little bit of time. And I thought it's better to talk at you while this is happening and it's slow. So maybe this is a good moment for questions.
Can I have a quick question?
Sure.
Hello.
Hi.
Hello. Yeah, I was interested in Tauri to begin with because I hope that there will be a sandbox file system underneath. Is that possible?
A sandboxed file system?
But I mean that Tauri itself is restricted to access just some designated directory.
That's absolutely possible. That's totally possible, yep. I mean, we try not to make that our expectation. I mean, one of our guiding lights is we want to base everything on a solid foundation of security and, you know, proper approach, but there's a million different developers out there with a million different needs, and I'll show you exactly what maybe you were asking about right now. This is the dev app, okay? So one of the things I can do is if you look up at the top, that's the name of the window bar. I will come back to that in a moment. I just pressed the set title, so let's change it to something else. And app set title changes. I think I can even put a heart in there. Yep. So UTF strings will also work there. And what we're looking at right now is this kind of test interface for our APIs. So let's say you want to send some event to Rust. Well, you're going to get a callback, right? So if you look down here at the bottom of my terminal, this is technically the Rust terminal here because we're running cargo, and it's
standard out. It's standard out for cargo and Rust.
Right, and so we also have the console here. Check all, and what is that? That's communication, I think. So this is a payload string. Register response. Right, so basically we are emitting an event. In Rust, we are, and now I'll show you how Rust handles that. In Rust, we are, okay, the event is called JS event. Here we have listening for JS event. Then we say got JS, that's the print line, that's basically your console log, right? Got JS event with message, and then we interpolate the message. some, this is a payload string, and then we're going to emit our struct, data, something else. We're going to emit that back to Tauri. And that's what we're seeing here, something else. So,
and just to make this super obvious, so you basically you've initted a new. This is your demo app. This is now running. You're running Mac OS.
I am on Mac OS right now. Right.
Okay, and so this is being popped up by the system. This is a system window. In fact, I can see in your menu bar on the top left, it actually says app.
Right.
So we're running that right now. Can you also, has Tauri already done support for menu bar apps?
By menu bar, you mean these things up here?
Yeah.
That is on our to-do list after beta, but
Awesome.
It is on our roadmap.
Awesome.
So what I would like to do now is I want to change this. I just don't like that style. So I'm just going to show you a quick bit of HMR. Let's say font family. Yeah, all right. Just because I don't like that other one. And I will save it. Now, Tauri just crashed. Well, it didn't crash. It closed because now we have a new source. With HTML, with files, we are actually watching the file system, right? And so if a file changes, we will actually respawn Tauri. So basically the dev window closes and we rebuild it. And now you see we have a sans serif. It's a very trivial example, but I didn't have to restart cargo run. I didn't have to do anything. It just took care of that for me. Now, if we were using something like Svelte or Vue.js that comes with a dev server, then in our tauri.conf.json here, we would just write something like HTTP localhost, whatever that port is, let's say 3000, right? And so now when you're editing your .svelte file, your Svelte dev server is going to transpile that down into JS, HTML, whatever, and serve that, I think it's over WebSockets, and that gets sent back into the Tauri dev window, and you also have HMR that way. So HMR means hot module reloading, and I love
slick.
it.
So what you were saying before, you're giving us a vanilla demo, but you feel free to use any framework that you want, and you can inherit the local dev niceties of that. Well,
Exactly.
where you ship, just like you're shipping static builds, static front ends anywhere else, this would get bundled into the app.
Right, and I mean, what we've experienced at Tauri is there hasn't been a system we haven't been able to work with. I mean, we've even worked with a couple of games engines that build. So like there's even a project called YEW, which takes Rust and creates WASM, and you can just inject WASM. I mean, there's even an example of Flutter on our examples repo. I think it's Flutter. I hope I'm not wrong.
Right.
But basically anything that is able to exist inside of HTML, CSS, and JS is going to work. Now, there are a couple caveats at the moment. One of them is that some web APIs are complicated. And we are working on them. I think like geolocation is tricky. Having access to the web camera is tricky. But I'm not that worried about it because we're still in alpha, and our task for beta is to do a couple things. We want to have a very elegant updating system that is secure and fast, and we want to make sure that our API is solid, and we want to make sure that our bindings are correct and not hogging memory. So once we've kind of gotten those three things nailed down, for us, that means that the beta is going to be the next step, right? And then in beta, there's going to be other things like having an app tray, like having, I mean, there's a whole roadmap. I don't want to go into it. I want to actually keep on here with my walkthrough. So there's a couple more APIs. Did I accidentally close that? I'm sorry. There's a couple more APIs that I do want to show you, especially because Guriai asked about locking to a specific folder. So I'm just going to copy the path of the icons folder, and I'm just going to read that directory. So now what we have there is a programmatic way of getting the path of, or getting the directory listing of a path. Now, there are a number of system paths that we already linked to. Let's say, I think to be kind of safe, I can show you my fonts directory. And there we go. We have all of my fonts. Let's see. The one that I want to try is, let's just check this one. Now, obviously, this is a demo. We don't care about properly rendering TTFs, but so you do have a render. And yep, that's it. Yonona Kafasat's regular. Good friend of mine. Shout out to Yonona. Great work. Best font designer in the world. But yeah, so what we can do is we can, from the Rust side, we can say, hey, there is a specific directory that I want you to look at, and just that one, and there's no escape, right? You cannot tell the web view to, if that's what you want, you could not, from the web view side of things, change the directory that the Rust side of things is looking at. It will be, if you construct it that way, impossible. So what did I want to show you? What else? Oh yeah, there was something I was let's go to this folder again, icons. Let's copy the path. And we're going to, let's just look for PNGs. How about that? Okay. And nope, why does it? Let's open the dialog. Okay, so now we are in the icons folder. And you can see, Guri, that it would technically be possible for someone to change out here. So you probably don't want to use the native interface. You don't have to, but what I'm going to do is I want to show you the logo. So I'm going to open it this way. Oh, that kind of sucks. You know what? I'm going to change that. Before we had the dialogue, I don't like that dialogue. I'm just going to save that. Great. HMR to the rescue. Where's my icons? There they are. Copy path. So let's try this again. It didn't work. Okay, do we, yes, I'm going to just figure out why. So
I think some of the question marks around sandboxing is a lot of us are working on systems that are highly portable, that like work in a browser, work in a desktop. And what we're realizing is the sandbox story on native desktops is actually terrible.
It is.
Because once you're on local desktop, you can just wander around anywhere on a user's entire system. And so
Yes.
one of the things that Fission is doing, so we've built an encrypted file system on top of IPFS, and have an authentication mechanism where apps only get access to a hierarchical tree. So that's what's fresh in our minds in looking at other systems now, and thinking about different ways to stay secure.
Well, you know, my general, maybe I should just pull up the patterns. And well, so one of the things that we've been working on is figuring out different ways that people can use Tauri. And so we've been kind of developing these patterns to the point where sometime around beta, you'll just be able to initialize a new app, create a new app according to one of these patterns. And there's a couple more coming up. But what's important to think about when you're designing your Tauri app is, you know, A, what's your security model? B, how much do you trust the people that are using your app, right? One of the very first projects to use Tauri is a project called GUI.js. And GUI.js actually was one of our focus projects where we worked together with the developer. He's from the core team of the Vue.js project. Akrum is his name. And he's responsible for the Vue CLI. And what he wanted to do was create an app where developers can manage all of their plugins. They have a CLI, and his model, though, his security model was, look, this is a developer tool, right? These are people who they know exactly which version of Node.js they have running on their system. You know, they understand the risks of third-party modules. In fact, they probably install millions of them every day. And so it's a little bit more of a open system. In fact, we are basically using Tauri just as a thin interface layer to a GraphQL service endpoint that is not shipped with the app, but managed by the app through some NPM commands that we're actually running from the Rust side of things. So in a sense, it's like a semi-managed system where it will automatically update your version of GUI.js if it detects that it's out of date. And it's not the most secure system because it's not pretending to be, right?
Yeah.
Now, if you're making a user-facing application with IPFS where the user has to hold their private key and then be able to, you know, craft the public key from that, and then they maybe have a session key, and at rest, the entire storage should be encrypted, but when they want something, it should be able to decrypt it. And you don't want the user to be able to traverse around the file system from the application itself. In an Electron app, you would have to go through a lot of bells and whistles to be able to do that, right? Because
Absolutely.
it's all JavaScript. Like that's my whole concern with isomorphism, like JavaScript all the way down. And what you end up with are these massive risks of, you know, for convenience, you've got window.electron in the actual web view or in the Chrome view or whatever it's called. And that makes it super powerful, but it's also an insane security risk. And even with like all of the security hatches battened down, so to speak, you are always going to be at just absurd risks with Electron. And I mean, you know, just kind of thinking, excuse me, out the back of my head, what I would recommend for your system would be what we're calling the kamikaze, which is based on the bridge pattern. The bridge pattern is described here where you have the binary bootstraps the web view. There's a JS broker that uses an API bridge to talk to a Rust broker, and the Rust broker has sub-processes. So you have this actor bridge that serves as a type of communication between the web view and the broker. Now, the kamikaze is a little bit more extreme in that we're using a specific type of one-time functions that we are injecting into the web view from Rust that are promise closures that are that use salts. So it's very much in line with a very strict actor model where a message lens is only used one time, right? So obviously we don't want people to be able to have replay attacks. And I mean, if you're interested in understanding more about this, then I highly recommend going through the patterns pages, because we try and explain these a little bit, and we're going to be expanding on them more. And we really love to have feedback on what you think this is about, and potentially even new ideas. We'd love to figure out ways of expanding this pantheon of patterns and making it more transferable.
Yeah, this is really great. I think this is a really a great way to, instead of just having a blank slate, this is really helpful.
And what we're trying to do mostly there, by the way, I'll go back to that screen, is we try to configure everything in our JSON file, because we need that JSON file when we're setting up the Node.js that we ship with your app, and when we're setting up Rust. So the claim is that with a little bit of configuration, you will be able to have this kind of setup out of the box. And where we're working toward is actually setting up the main.rs file with what you need. So yeah, I mean, we're really trying to get the DX to the point where it's easy to get up and running. And once you've gotten over the hump of understanding how Rust works, well, you know, as a matter of fact, other than this tiny bit of Rust here, which is pretty much copy paste, the entire app that we've been working on is all JavaScript. Like, I mean, come for the Rust, but stay for the JS. It's a terrible claim, but basically what we're trying to do with the API is lower the barrier to entry for people who want the safety guarantees of Rust and the very strict approach to access of the system assets that we can offer from Tauri. You know, so it's about configuration and it's about a good API. And you know, while it's building, the reason why it's about the API is because at some point in the not too distant future, after we've gotten beta well under our belt, we're going to start making a Dino implementation for the backend. So if you want, you can have a Dino backend instead of Rust. And you can have you could have a Dino backend and a Vue.js front end, or a Svelte front end and a Go backend, right? I mean, that's the point of having this API is it's a great interface to be able to switch out. Oh, by the way, while this is happening, what you're seeing here is we're building a DMG, and that's the whole stuff, right? That the DMG needs. You know, you have that folder and icon, and in that packaging system, you can also set up licensing and So let's track that down. All right, that file is currently following the Rust standards of dumping it to target, dumping it to bundle. I'm not going to bother with the DMG. Basically, you would ship that app DMG. That's what you would upload to GitHub. But for now, the one I'm interested in is the app.app, where we have the Mac OS, we've got our resources, our icon S, the info plist, and I know I said I was going to do a little bit of instrumentation, so let's try to do that. I just ran the Tauri build command, so we now have a fresh built binary. I wonder how big it is. Let's find it in Finder. 3.9 MB. That's not bad. I mean, it's probably because I've included the entire, I've whitelisted everything, and I have not done binary, what's it called? Packing. So the binary itself hasn't been compressed.
Hey, we should be cheering at this point. 4 megs is super tiny for a desktop class machine.
Yeah, but it's not good enough for me. So let's find our development, publishing, bundle. Yeah, this is also new for me too. It's development docs, usage, development. No, it's not API, is it? No. You know what? I'm just going to go off screen for 1 second and check out our wiki. We haven't yet installed the search feature, which will be helpful. There it is. Hello UPX. I was just looking for my UPX command. So I'm going to just have that running in the background. UPX is a GPL licensed binary zipper, if you will. And that's kind of my final step when I'm trying to get things small. We also, let me find our cargo toml. We also use some specific release flags. I mean, basically, we are, oh yeah, wow. Did I break a megabyte? 1.4. Yeah, I got to work on the ICNS, but I mean 1.4. That's okay for me. It would be smaller if we hadn't whitelisted everything, but I'm not going to go into that right now. So what I am going to do is try to open it, and I didn't test this before, so it might crash. If it does, I'll have to do it again. Oh, okay. Let's send an event to Rust. Nice. Well, can we change the title? We can. Let's grab a file, copy path. Let's just do that. Wait a second. Did you notice I can't inspect my source? It's kind of a pain. No, it's not. It's actually what you want. You don't want people inspecting your source. You don't want debugger tools in your release. Like, it's just, okay, maybe there's a valid reason for it, but not only will that bloat the size of your app because it's just adding a whole bunch of stuff you don't need, it's a great way for people to reverse you. So let's read that. Great. We've gotten that. I'm going to copy it. I want to see that. And there's my icon. Great. So we have just validated that the dev works and the build works. Now, one last question for you. Do you remember, am I using a server? Am I using a localhost server or not? I forgot. Let's check the conf. I am. Well, I don't want to. I don't want to have a local host flying around. I mean, why? Like, that's the way everyone's been doing it, and people, they ship a local host server because we're basing our web tech on, or we're basing our apps on web tech, and modern web tech is like, oh yeah, you got to have code splitting, you have to have lazy loading, you probably need dynamic imports, and all this other stuff that's designed around a different ecosystem. You know, it's designed around devices that have poor connectivity, and you definitely don't want to be downloading 5 megabytes all at once before the app is working. And it's a different model, right? And you know, the thing that we're particularly happy with is that we don't have to ship a dev server. Excuse me, we don't have to ship any kind of server anymore because of the way that the Rust communicates with the web view, right? So that just finished. Now, over here, while it's doing that, yada. You know what? I'm just gonna let it finish before I open up Frida. We're at about 10 minutes of time. And for those of you who don't know what Frida is a project from a company called Now Secure. And they also make another tool called Radar 2. And these two tools are very important for reversing your binaries. And you might be like, well, that's only something that attackers do, right? And just a question, if you're reading, or listening to this, watching this, and you've ever shipped an Electron app, have you ever decompiled it? Have you ever analyzed it? Have you ever tried to figure out what's it doing back there? And maybe you have, maybe you haven't. I feel like it's a really important part in the life cycle of an application that you as a developer look, at least from the perspective of the attackers who are going to be attacking you. Maybe not intentionally, maybe there's just a virus on that person's computer or phone, but your app is going to be under attack. I personally consider the user device as already compromised, probably because it's already got iOS and Android on it, or you know, Windows, Linux. That's, you know, a mixed bag. But generally speaking, the perspective I take is the user device is compromised. So what are we going to do about it, right? And we isolate processes, we encrypt everything at rest. You know, the kamikaze is all about one-time messaging and you know, salting the message name. So you've got a random message name. You know, we make it as hard as possible. We actually try to make it so improbable for static analysis to work on our apps that people will have to try find different vectors. Okay, so that finished. And now I'm going to start frida-trace. Frida is a dynamic instrumentation application that allows you to inject JavaScript into running applications. There's millions of ways to use it, but its claim to fame is that nowadays you can instrument iOS apps on iOS devices that haven't been jailbroken. You can instrument Android apps, you can instrument Unix apps, you can instrument Linux, Windows, Mac apps, probably a couple more of the more rare operating systems out there. And one of the very useful tools in that toolkit is called frida-trace. And so that's what I'm going to open up here. I'm going to make this a little bigger because it's going to just kind of explode with Am I doing the right one? I don't have the debug. I didn't make the debug. Did I make the debug? Yeah, let's just use the release because we're running out of time. So what this is going to do is frida-trace is going to be called. I'm going to say, hey, I want you to listen to this binary and open it, instrument it immediately, and everything that you listen to, I want you to show me. Okay, so I'm just going to move the app over here a little bit and show you a little bit more of, hello, about what's going on. So where am I? There. So what we have is a lot of stuff that's like, this is related to the app, these kind of blue flags. And, this is like, oh yeah, okay, system strings, like system strings. Oh yeah, of course. It's an app on Mac OS that has to know what language the system is running at this moment, right? And so on, 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 and so on. Now, I'm going to open, I think that's the one. Yeah. Now, let's send an event to Rust. Right? Now you see here at the bottom, that is the message we saw in the Rust console. I want you to remember that. Now that's important. What that basically means is, we have to be careful about logging to the Rust console, even if you're not expecting there to be a Rust console, because, excuse me, you're running as a bundle and you're not shipping a console. It's running as a binary. You're not running it from the command line. But still, that's available for an attacker. And basically, what we want to do is we want to make it invisible. We don't want our stuff to get leaked, right? So I'm going to show you another one this is the payload string. Let's call a request. There's a API call. Oh yeah, sorry, I forgot to tell you, you can also have it open a window. Let's do that again. Right, so it will open a window for you. Now notice that's not leaking, right? Those clicks, right? That event from WebView propagated to Rust, and that used the system available open command to send a message to the Chromium renderer, whatever, to open that tab, right? That means we did a good job. And just to kind of put the icing on the cake, we're going to set the title to "Thanks for listening." And the app title has been changed. There has not been a trace available in frida-trace, and we sent a message from the web view to Rust and told Rust to rename the window decorator of the web view, and we didn't leak it. So I think that's about everything I had prepared. Maybe you've got some questions. If not, I unfortunately only have about 5 minutes before I have to get back to work. I'd just like to say a big shout out to everybody on the Tauri team, like the best people I've ever had the opportunity to work with in my life. Creative, hardworking, innovative, and always open for new people to come on board, and also for everyone here listening to the talk. And yeah, thanks very much.
Awesome. Thank you, Daniel. That was super great. We've only got a few minutes for questions before Daniel has to go. Does anyone have questions?
I wrote a few in the chat, so that's the quickest way. If you can look at it.
Oh yeah, definitely. Like, visit your Discord and chat with me there. It might be a little async for an hour. I have a meeting to get to, but I will definitely do my best to give all of the answers that I can.
Yeah, and Gary, I think your question about opening tabs in browsers, this really is for shipping apps that use web views. So, I mean, theoretically, if there was a system URI handler, you could send links, maybe.
Right. That's something we're working on. We're working on deep links. There's an open PR, but we had problems with the Windows implementation and the actual message passing within the deep link, and it's under investigation. It probably won't land before beta.
Awesome. Yeah, no, this is really great. I mean, I'm really inspired by some of these directions coming together. I had a quick question around, so at the Rust layer is where, of course, you can then sort of implement native Rust stuff as well. So you've given examples of where Tauri's done all the work of doing the Rust layer, and you can just stay in Techland, but you've got these other patterns. So as a purely theoretical example, we could implement libp2p and IPFS in Rust and communicate natively from there. Yes?
Well, I mean, libp2p, yes. I think IPFS would probably require that you spawn a daemon or check to make sure that that daemon exists, but that is totally within the realm of well, I mean, gosh, if you're going down to library level, you could absolutely create your entire system within the main RS, or create additional glue code. You can call additional binaries. I mean,
so it's very similar to this sort of like React Native mode where you can mix and match web tech and compiled code and decide to implement things on one side or the other.
right, except if you take one thing away from this talk, that is thin interface, the front end, the UI, the web view should really just be focused on the GUI. And the reason for that is that it's still JavaScript. And
yes.
You might be able to get a web worker in there, but that's still going to be most two threads. By offloading the heavy lifting to Rust, I mean, it's even better than WASM, because if you offload it to Rust, then you own all of the threads you need. You know, you can gain the superior horsepower of Rust, and like that's my advice. Like, just use the front end to be beautiful and slick, and do all of the heavy lifting in the back end.
Awesome. I am going to stop recording. Thank you very much.